When we eat, our pancreas starts producing insulin that takes glucose into our tissues to be used for energy. Food energy is calculated in calories, and consuming excess calories means we are eating more than our body burns off in a day. Some of these calories are consumed by the autonomic processes such as breathing, digestion, and heartbeat, etc. Rest of the calories are sitting there waiting for us to take action. As a result of physical activity like walking, exercising, gardening, and household chores, we burn calories. If we don't do enough movement to get rid of all the calories, excess glucose is stored as glycogen in the liver. The glycogen stores last for roughly 24 hours, but when we don't eat anything for next 6 to 24 hours, insulin levels start to fall and breakdown of glycogen begins. That releases stored glucose for energy. In the fasting state of 1 to 2 days, a process begins in the liver called gluconeogenesis. This process produces new glucose from amino acids. In non-diabetic people, glucose levels fall but stay within the normal range. The next stage is called ketosis. This starts after 2 to 3 days during the fasting period. Continuous low levels of insulin during fasting stimulate lipolysis, the breakdown of fat for energy. Triglycerides, the storage form of fat, is broken into the glycerol backbone and 3 fatty acid chains. Glycerol is used for gluconeogenesis. Fatty acids may be used directly for energy by many tissues in the body, but not the brain. Ketone bodies capable of crossing the blood-brain barrier are produced from fatty acids for use by the brain. After 4 days of fasting, approximately 75% of the energy used by the brain is provided by ketones. In healthy humans, the body is continually making a small number of ketones to be used by the body for energy. Even overnight while sleeping, the level of ketone bodies in the blood increases. After 5 days of fasting, high levels of growth hormone maintain muscle mass and lean tissues. The energy for maintenance of metabolism is almost entirely met by the use of free fatty acids and ketones. Increased neuroepinephrine levels prevent the decrease in metabolic rate. The human body has well-developed mechanisms for dealing with periods of low food availability. As a bottom line, the process is to switch from burning glucose, that is short-term, to burning fat, that's long-term. Fat is simply the body's stored food energy. In times of low food availability, stored food is naturally released to fill the void. The body does not burn muscle in an effort to feed itself until all the fat stores are used. So we have come to a conclusion that fasting helps burning fat and excess glucose from the body. This is one of the many benefits of fasting. Another major benefit is stem cell regeneration. This is more exciting bit. Stem cells are the body's raw materials. Blood cells, brain cells, heart muscle cells, and bone cells are made from the stem cells. No other cell in the body has the natural ability to generate new cell types. During fasting, the system tries to save energy. And one of the things it can do to save energy is to recycle a lot of immune system cells that are not needed, especially those that may be damaged. Prolonged fasting forces the body to use stores of glucose, fat, and ketones, but it is also breaks down a significant portion of white blood cells. This depletion of white blood cells induces changes that trigger stem cell-based regeneration of new immune system cells. According to a study, prolonged fasting also lowered levels of IGF-1, a growth factor hormone that is linked to aging, tumor progression, and cancer risk. Life lies in the balance of the two. The cycle of life is feast and fast.